This is Chapter 9, Test Addition Review. You should watch the whole thing. That will help you review for the assessment that we're going to have tomorrow. First of all, in Lesson 9.1, we talked about exponents. If you had a base of 2, and you had it to the third power, the way that you would write that out would be 2 times 2 times 2. You would write the base of 2 3 times. So the opposite of that, if you had to write something, a product with exponents, let's say that you had 7 times 7 times 7 times 7 times 7, and you had to write that with exponents, you would take the base of 7 and write the exponent of 5, since there's 1, 2, 3, 4, 5 sevens. So that's writing with an exponent. Then you may have to evaluate something with an exponent. Okay, so if we had, let's say, 3 times a to the fourth power, and a is equal to, let's say, 5, then you would have to plug the 5 in for a and show your works like this. So you would have 3 times 5 to the fourth power. If you follow PEMDAS, you should do the exponent before you do the multiplication. So you would have 3 times 5 times 5 times 5 times 5. Well, while you're evaluating that, the first two 5s, if you multiply, you get 25. And the second two 5s, you get 25. So when you multiply 25 times 25, that really is going to be 3 times 625. If I multiply that out, 3 times 625, that is 1,875. So you would just have to multiply that or use a calculator. That is evaluating using exponents. All right, the next lesson that we talked about products of monomials. So if we had something like 3 to the fourth times 3 to the eighth, we would leave the base of 3 alone and add the exponent, so it would be 3 to the 12th. If you had something like x to the fourth times x to the seventh, you would have x, and then you would add the exponents again to the 11th. But if we added coefficients to that, so let's say 2y to the fourth times 3y to the fifth, the 2 and 3 are different, so you have to actually multiply those two. So 2 times 3 is 6, and y to the fourth times y to the fifth, well, you leave the y, and you add the 4 plus 5, so 6y to the ninth power. That's finding a product of two monomials. We went on and we talked about division. So if you had x to the eighth over x to the third, you would leave x alone and you would take 8 minus 3 to get x to the fifth. Because you have 3 on the bottom and you have 8 on the top, you cancel all 3 of those out and you take 3 away from here, you get your x to the fifth. That is monomial division. Next, we dealt with negative exponents, and the key to negative exponents dealt with taking something to a negative power, let's say 2 to the negative 3, to a denominator of a fraction. You would put 1 on top because you can't leave it blank over 2 to the third. So if we had something like 8 to the negative fourth, to get rid of your negative exponent, you'd write 1 over 8 to the fourth. So you cannot leave a negative exponent in an answer, and to remove the negative exponent, you take that base and the exponent to the denominator. That takes the negative away. We moved on talking about scientific notation. So if we had 2.7 times 10 to the 5th, and you had to write that in standard form. Standard form is just normal numbers, the way that you're used to seeing them. If we had 2.7 times, that should have been times 10, sorry, 2.7 times 10 to the 5th, then you would take your 2.7 and move your decimal to the right, since it's a positive, to the right 1, 2, 3, 4, 5 times, leaving 4 empty waves. You always fill empty waves in with zeros. And now I'm going to take my number, 2, 7, and 4 zeros. I'm going to write it away from those empty waves to kind of clean it up a little bit, and start on the right and count 1, 2, 3, put my comma in. So that would be 270,000. So let's take my 2.7, and this time let's take times 10, let's say negative fourth. Alright, since it's a negative exponent, you don't move the decimal to the right, we now move it to the left. But I got to move it 4 times. So 1, 2, 3, 4, and put my decimal in. I have created 3 empty waves. Fill that in with 0. So the decimal is 0.00027. Okay, very small decimal. When you have a negative exponent, it moves the decimal to the left, just like negative numbers on a number line. What we added to scientific notation this year was scientific notation with the operations. So what I mean is something like this. If we had 3.2 times 10 to the 7th, and we wanted to add it to 2.1 times 10 to the 5th, in order to add those, these exponents have to be the same thing. Okay, and if they're not, you have to make them be the same thing before you can add them. So you take the bigger exponent number, so the 3.2 times 10 to the 7th. And what you're going to do is you're going to move the decimal over to the right 1 time. That makes this become a 6. Well, we need it to be a 5, so you're going to move it 1 more time, putting in a 0 there, and that's going to make it a 5. So now it's matched up, and what it really is 320 times 10 to the 5th plus 2.1 times 10 to the 5th. They've got the same exponent, so now what we're ready to do is to take these two numbers, 320 plus 2.1. Now make sure you line that decimal up, because 320 has the decimal at the end. You don't see it there. And add those numbers. So 322.1 times 10 to the 5th, but that is not a good scientific notation number. You must move the decimal back. Scientific notation says that this number must be between 1 and 9.9. So every time you move it back, it makes the decimal, or the exponent, go up. And we're back to this original decimal over there, or exponent of 7. So 3.221 times 10 to the 7th. That would be what we did with adding and subtracting exponents and scientific notation. So moving on, we did something called power of powers. And that just means that you had something like x squared to the 3rd, and we would multiply those. It'd be x to the 6th, because really that is saying that you have x squared 3 times. Well, if you had x squared 3 times, there's 2 plus 2 plus 2. Well, that's x to the 6th. So what if we had a number let's say 5 squared, and let's take that to the 5th. So it would be 5 to the 10th power. Or if we had 2x and we're going to cube it, let's say, that makes 2 to the 3rd and x to the 3rd. And 2 to the 3rd, 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So it would be 8x to the 3rd. A power on a power means that you multiply the exponents of the variable. Everything inside the parentheses must go to that exponent. Okay, the last thing I want to address is linear versus nonlinear. Okay, linear versus nonlinear. And on graphs, it's pretty cut and dry. Let's do one of each. I'm going to change my color to blue. So something that would be linear, of course, is just a straight line. And you would use the explanation that it's linear is because it is a line. Okay. Nonlinear would be something like this. Maybe a parabola or something with a curve, and it is nonlinear because it has a curve. And that definitely makes it not a line. Okay, also for equations, anything that could be y equals mx plus b was linear. Anything nonlinear would be something with an exponent. That was definitely nonlinear. Something with a variable and a square root, that was definitely nonlinear. And anything that had an x or a variable in a denominator, those were all nonlinear. Okay, if you could make anything y equals mx plus b, it definitely was a line. And that concludes my review for your test add-on for Chapter 9. If you feel like you need to watch this again, you should, but we're going to be testing, and you need to be able to answer questions just like this.